All right, this video is designed to introduce you to the last of our points of concurrency, the Orthocenter. Like the other points of concurrency videos, you'll need your compass and straight edge, and we're going to go ahead and get started and construct the altitude to each side in the triangle below. Like always, we want to make sure that we do this carefully and precisely. Before we can construct it, it's helpful to know what the altitude is. Hopefully you remember from our previous discussions that the altitude is going to connect a vertex to an opposite side in such a way that the angle formed with the opposite side is a right angle. So I'm going to say vertex to opposite side, or it can be an extension of that opposite side in such a way that it forms a right angle or is perpendicular. So in other words, if I think about what this might look like in terms of a sketch, if this is my triangle, I want to go from vertex A to side BC in such a way that a right angle is formed. I need to go from vertex B to side AC in such a way that a right angle is formed. And lastly, I need to go from vertex C to side AB in such a way that a right angle is formed. All right, so we're going to use a construction that we haven't used since before winter vacation, and that is constructing a perpendicular from a point to a line. All right, if I want to construct from vertex A, I'm going to go ahead and I'm going to grab my compass. I'm going to begin by putting the point of my compass on point A, and I need to draw an arc that intersects side BC in two different places. Now, it just so happens that one of the arcs I drew intersects side BC, the other of the arcs does not. So I'm going to grab my straight edge and I'm going to extend side BC. Then using those 2 points of intersection as my two centers, I'm going to grab my compass again and draw a second pair of arcs that intersect. And I'll then take that point of intersection and connect it, or use my straight edge to connect it with vertex A. I guess that's as close as the smartboard will allow me to become or to get. And then I'm going to do the same thing for vertex B. I want to put the point of my compass at vertex B. And I guess I'll make all these blue. And again, what I'm going to need to do here is I'm going to need to grab my straight edge, and I'm going to need to extend side AC, probably in both directions, it looks like. What I really want to focus on are the points where the little blue arcs intersect side AC, and those are going to then become the centers for the next pair of arcs that I'm going to draw. And again, I'm going to grab my straight edge, use my straight edge to connect vertex B to the point where those two arcs intersect. And then lastly, I want to repeat the process one more time using vertex C as the center. And again, I'm going to need to extend one side of that triangle. And like I did the first two times, I want to focus on where those arcs intersect those sides, or that side. And those 2 points are going to become the centers of my last pair of arcs. And at this point, I'm done with the compass, so I can go ahead and put that away. And it looks like I did a pretty good job with my orthocenter here. This point where all three of the altitudes of the triangle intersect, I'm going to call it point X. The name for that point is the orthocenter. So the orthocenter will be the point of concurrency of the three altitudes of a triangle. Now the orthocenter on your paper may look a little different than the one on mine because I had to adjust the triangle on my paper to get my compass to be able to perform on the smartboard. But the important thing is all three of your altitudes should intersect at one point. And again, the name for that one point where all three of those altitudes intersect is the orthocenter. Unlike the circumcenter, the centroid, and the incenter, there are no special properties that you need to be aware of for the orthocenter. All right, so that is the end of my presentation here on Orthocenter. The next time that you come to class, we're going to practice with this a little bit again on the Nspire and play around a little bit to see if we can make the orthocenter go inside, outside, and on the sides of a triangle. Till then, if you have any questions, of course, write them in the margins of your paper so you can remember to bring them to class with you and when you come in the next time.